Okay, so this video tutorial looks at the mathematics strand of patterns and algebra, and more specifically we're going to focus on using the sum and product rule to help factorize quadratics. Okay, so to understand how to factorize quadratics using the sum and product method, you need to understand what sum and product actually mean and where we get them from. So remember that a quadratic trinomial is an expression in the form of ax squared plus bx plus c, which we've got here, where a does not equal 0. All right, it has three terms, hence trinomial. Now, when we're trying to factorize these terms, all right, we're going to put or eventually get our algebraic expression into the brackets of x plus a and x plus b, okay, where a and b can be positive or negative numbers. But in order to do that, all right, we need to understand that a and b, when added together, actually give us our middle term of our quadratic. In this particular case, I've written down p, all right? And when you multiply a and b, that actually gives us our q value. So if you look at our example that we've got down here, all right, we've got a p value of 7 and a q value of 6. Now, we need to eventually get it into the form of, or get our quadratic that we've got as our example, factorized into x plus a, x plus b, where a plus b equals our sum. In this particular case, the sum is p in our value, so that's going to be 7, and a multiplied by b, which is our product, q in this particular case, is going to be 6. So we need to think about what two numbers can I multiply together to give me 6, but can I add together to give me 7? Now the answer is obviously 1 and 6, because 1 plus 6 gives me 7, and 1 times 6 gives me 6. So therefore, first thing we're going to do is put in our brackets and put in our x's. We know it's always going to be x. We've got a positive 1 and a positive 6 as our numbers. So our sum is 7, our product is 6. Our numbers therefore are positive 1 and positive 6. So let's have a look at a few examples. The question says factorize the following using the sum and the product method. All right, in our first example, we have a sum of 5. I'll use S for sum. The sum is 5, so when we add together we get 5. Our product is 6, so when we multiply together we get 6. The first thing I can do is I can put in my x's, because I know there's going to be x and x. I now need two numbers that when I add them together give me 5. When I multiply them together give me 6. If you're not sure how to go about it, you can always look at the factor pairs of 6. Okay, the factor pairs of 6 are 1 and 6, or 2 and 3. 1 plus 6 is 7, that doesn't help me, but 2 plus 3 is 5. Perfect, that must be my factor pair. Because these are both positive symbols here and here, that means that there's going to be positive symbols here and here, and then I can just go 2 and 3. It doesn't matter if you do 2 and 3 or 3 and 2, it doesn't really matter. All right, our second example, we have a sum of negative 18. We have a product of positive 81. Therefore, I need two numbers that when I add together give me negative 18. When I multiply them together, they give me a positive 81. When I'm adding, they get negative 18. And I know this is a positive number. So there's a positive here, which tells me that my two numbers that I'm looking for are going to be positive numbers. Okay, sorry, are going to be the same, not necessarily positive, but they're going to have the same symbol in front. So it's either going to be 2 positive or 2 negative. Because this is a negative number, negative symbol here, I know the two numbers I'm looking for are both negative. So I'm going to have negative number and a negative number. What two numbers do I get that times together to give me 81, but add together to get negative 18? Negative 9 and negative 9 are going to be the numbers I've got. So I can say x minus 9 x minus 9, or alternatively, I can write x minus 9 all squared. So when you're looking at these quadratics, like I really badly tried to explain, have a look at the symbols, and that'll help you with what type of factor pairs you're going to have. We'll go through some more example questions in a minute. Here's another couple of examples. Factorize the following, use the sum and product method. If you can, try and take out a common factor first. For example, in our first one, I've taken out a common factor of 3. That leaves me with x squared, take 7x plus 6. All right. This is very similar to factorizing the first example we went through. All right, but we can ignore the 3 now because it's a common factor, it's been taken out. We just need to factorize the quadratic. In order to do that, we have a sum of minus 7 and a product of positive 6. This number, this symbol here is a negative. I know my two numbers are going to be negative because of that. All right, and I know they're going to be both negative because this answer is a positive, and a negative times a negative gives me a positive. My factor pairs I'm looking for of 6 can be 2 and 3 or 1 and 6. I know it's 1 and 6 because negative 1 times negative 6 gives me positive 6 as my product. Awesome. And negative 1 take away 6 gives negative 7, which is my sum. So therefore I end up with 3, x take 1, x take 6, because I've put negative 1 and negative 6 back in. In the next example, I'm going to rewrite this and have negative x squared out the front, just to have it in the form of ax squared plus bx plus c. I end up with positive 6x take 9. I'm now going to take out a common factor. All right, the common factor is going to be minus 1. That will leave x squared take 6x plus 9. Now I know here, again, similar to the previous one that I've just done, the first symbol that I come across in my quadratic is going to be a negative, and the second symbol is going to be a positive. I know that my sum needs to be negative 6, and my product needs to be 9. I know, therefore, that I'm going to have two negative numbers, and I need two numbers that when you times together give me 6, but when you times together give me 9, but when you add give me 6, negative 3 and negative 3. Therefore, I've got negative 1 outside of my two brackets, and I can just put negative 3 and negative 3, or I can rewrite this as negative 1 outside of x take 3 all squared. Okay, I'd now like you to have a go at some practice questions. On the next slide, they'll come up. If you can pause them, have a go at them. When you think you've got the answers, go to the last slide and we'll check. So, as stated, here are the practice questions. There's only 2 of them. If you could pause the video, have a go at them, and when you think you've got the answers, continue the video and we'll go through the answers on the last slide. Alright, so let's see how you went. First one, factorize x squared plus 8x plus 15. Well, I know my sum is going to be 8. My product is going to be 15. First thing I can do is write my x's in brackets because I know they're going to be there because x times x gives me x squared. I now need two numbers that when I multiply them together give me 15. When I add them together give me 8. Factor pairs of 15 are 1 and 15, 3 and 5. Excellent. I know straight away 3 and 5 works. They're both positive. Plus 3, plus 5. Done. There's my answer. In the second equation, you can see that there's a coefficient in front of the x squared. I'm going to see if I can take out a common factor first. I think I can because I've got a common factor of 2. So I'm going to take 2 out the front. That's going to give me x squared, take 4x, take 21. All right. I'm now looking for a sum and a product. My sum is going to be negative 4. My product is going to be negative 21. So I've got 2 bracket x, bracket x. Now, I need two numbers that when I multiply them give me negative 21. I know when you multiply and you get a negative number, one of the numbers has to be a positive and one of them has to be a negative. Factors of 21, that when you add them together, or add a positive one and a negative to the other, and you get negative 4. I'm going to say 3 and 7. So if I've got positive 3 and negative 7, positive 3 takes 7 gives me negative 4. Perfect, that works. Positive 3 times negative 7 gives me negative 21. That works. So I can go positive 3 take 7.